Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this morning. Mad science is about building things that make people say, I didn't know that was possible. Today, I'm super excited that we're joined by Gio Delgado. Hey, Gio, how's it going?
Hey, Faraz. Going
Hey,
great.
super glad you're here.
Yeah, thank you for having me today.
Yeah, of course. So I'm super excited that Gio's joining us. He actually studied economics and then taught himself how to code, and now he's starting a software company. I guess it's your second that you've started, right?
Second foray. Yeah, this is second time being an early stage software developer. Yeah.
That is awesome. And you also work on open source as well, right?
Yeah. So related to today's presentation, I work on a small package that kind of bakes in all of the ideas that we're going to be talking about today into this nice, convenient package.
That's awesome.
And some other things as well too. I just realized Elm. I'm a really big fan of Elm, so I have some other Elm stuff I work on. Yeah.
Oh, that's awesome. Cool. Is that any of that going to be in the talk?
Kind of. I mean, Elm uses algebraic data types. You don't really see it in the documentation because that's kind of like a philosophy of Elm itself, of trying to be as non-intimidating as possible. But yeah, like Elm has inspired me and definitely inspired this talk for sure.
It's awesome, and it's also your first ever public talk. So welcome to the speaking scene, I guess. I think this is a good place to give a first talk. So congratulations, and that's awesome.
Thank you.
So cool. Yeah, you can take it away whenever you're ready.
Alrighty. So let me switch over to my browser. Trying Notion for the first time as a slide tool, and I think it worked out pretty well. So yeah, today's talk is about type-safe errors with algebraic data types. So I want to start out with a problem, or not necessarily a problem, but sort of the context of the conversation today. I want to just show some examples of situations in which everyday code that we use may or may not throw. So I'm assuming that most of us here are familiar with TypeScript, but if we're not, if we're JavaScript developers, what I'm writing on the right-hand side here, just for context, is the return type that you would see in TypeScript. So if I have a variable that I declare for JSON parse, the variable would end up being any. So anyways, the exercise is here, for you to ask yourself, to think about for a second, does this throw, and in which circumstances does it throw? Here's another example. So this is yet another method that we as JavaScript developers use basically every single day. And the question again is, does stringify throw? And if it does, in what circumstances? Also keeping in mind again that if we were using TypeScript, our variable would be a string. Here's yet another example. So we're always creating dates. This is something that in TypeScript compiles. So this is actually technically valid TypeScript, but it's kind of ambiguous. If I pass in an empty function here, like what does that really mean? And again, the question is, does this throw? Does it not? TypeScript definitely can't help you there. Again, this variable would be considered a date. And if we're familiar with Axios, if we're not, Axios is kind of like a third-party version of Fetch. So if you've used Axios, would you know when, in which circumstances would it throw? Again, does it even throw? I'm not trying to suggest that it does throw, but maybe it does. And then one last example here is for those of us that are a bit more mathematically inclined, we would know that division by 0 is undefined. Like technically you can't really divide by 0. It's totally meaningless. But TypeScript doesn't think that. And so the question again is, does this throw? So in general, there's some observations. So again, yeah, some of those examples throw and some of those don't. And we can talk a little bit later if we have time about exactly like what are those circumstances. But in general, it's kind of ambiguous. You know, like maybe there's like a committee out there in the web that decides like when something should be thrown and when it shouldn't. But in general, it's like it's quite ambiguous. You know, at least for me, I don't really find it to be quite to be intuitive around like, you know, why does one thing throw and why one doesn't, and instead return like some weird ambiguous thing. And the other thing to notice that I kind of emphasize is that TypeScript's not really telling you, you know, whether a function throws. It just says, well, if you create a date, then you're going to get a date, or if you stringify something, you're going to get a string. But something that I like to think about, or my, I guess, I'm a little OCD, I would say. And I like to think that if something can go wrong, so like if an exception can be thrown and we don't have like a try catch, for example, then inevitably one day something's going to go wrong. So let's just keep going here. So I guess like in general, you know, sometimes people might say, you know, you should know this. You should know as a developer, hey, you know, you're getting paid to know these things, to know that stringify will throw in this circumstance, but it won't throw in that circumstance, and division by zero may throw in this circumstance or it won't. You know, my belief, it's kind of unfair to like just assume that someone's going to know all of these things. And as a side comment, I have a whole bunch of bonus content, I guess. Like I just kept going and going on this slide deck, but I had to omit a whole conversation or segue on, you know, the idea of just using try catch. But I'll share the slide deck. I'll probably just tweet it, and there's a whole bunch of content at the end that we can talk about, or yeah, later that we can cover. So anyways, how do we make, the question is, you know, now that we are hopefully on the same page of, you know, it's not entirely intuitive why something throws or when something throws or when something doesn't throw. We can make systems more intuitive, or functions more intuitive, or code more intuitive by using algebraic data types. So let's do a quick, oh, and actually before I get into it, I just want to say that I will just abbreviate in the text a lot of the times, algebraic data type with ADT. Yeah, just so we're on the same page. So yeah, let's do a quick crash course on what an algebraic data type is. And I promise you that it's a lot simpler than the name or even this function that I wrote here. But basically, an algebraic data type is a type that you have created from other types. So in the context of at least TypeScript, or most other languages with this functionality, we have sum types and product types. So I guess like conceptually, you know, like the above equation kind of has that same idea. So we created a new value from a product and a sum. That's kind of abstract. So let's get into an actual example. This is something we do a lot. So as TypeScript developers, or even in JavaScript, right? So like just because in JavaScript you don't have types doesn't mean you're not thinking in this particular kind of way. You know, we have JSDoc, and in JSDoc you can annotate things like this as well. So this is a sum type, and you can have any number of combinations. So you can just keep saying or. And I guess, you know, the way that you can say this in English is, yeah, a nullable string is the sum of these values. So let's keep going. Another example is, let's say you're writing a Sudoku solver. Sometimes people might just treat the numbers inside of a Sudoku board as a literal integer, or, well, in TypeScript you don't have integers, but we would use number. But that's kind of ambiguous, right? Because like maybe there's a weird logic error where you accidentally enter the value -1000 into your Sudoku board, and that makes no sense. So you can use some types to model your system in a slightly better way. Here's an example of a binary tree using some types. But yeah, so I think those examples might be a little bit contrived. So I do have an example here. I admittedly never got around to actually implementing this, but basically the getMonth function returns a number right now, but why can't it just return literally these values? So that's what I was proposing. Where did I write it? Oh, there we go. So the actual type should be something like this. So that's a more realistic example of something that or a use case for some types that's something that we would use every day. So anyways, I'm going to quickly just hover over product types because we don't really need to cover them specifically for errors today. But basically, a product type is just sort of like you're just grabbing a whole bunch of types and you're like merging them together to create a new type. So for the case of today, that's all we kind of need to know about product types. And if we wanted to kind of bring it all together, we could define the entire JSON data structure or the specification using both sum types and product types. The interesting thing for just by definition of an algebraic data type is that the values inside your definition can themselves also be algebraic. So for example, in this particular definition of JSON, we have product types as part of the variance of our larger sort of sum type. But this, I think, is kind of like a little abstract. And again, what does it have to do with exceptions? So and errors. So let's kind of dive into why I'm alluding to this. So basically, the whole point is that you can replace most of your code that throws with code that simply returns a different value to signal something went wrong. So you might be confused or skeptical. This might not seem practical at all. But believe me, this is the norm. It is super common. It's like the standard in many languages. One that's really notable is Rust. I think people don't really consider Rust to be functional. Some people do, I guess. But this is kind of the norm in Rust, which is kind of interesting compared to, say, something more esoteric, such as Haskell. And yeah, Swift is also adopting this idea as well. So anyways, let's go into some examples that we had in the past or at the start of the presentation. So the answer to this, if you didn't know, is that division by 0 in JavaScript returns nan. And it's like, is that useful? Like why is nan also, like, something I find really confusing is like, why is nan a number? It should be technically its own thing. It literally means not a number. So anyways, here's the implementation of what it would look like to distinguish between our errors using algebraic data types. So rather than simply returning a number, now we in our code we have written, or sorry, in our types we have written that, hey, this function could actually fail because we're dividing by 0. So maybe I'm doing a refactor and I've just like commented this out because maybe that's what I had originally. All I have to do is return an error or return a new value. If we go to this example, so this example is a little bit different because we are using a third-party library that's already, we obviously can't change the definition of JSON parse. We didn't write it. But what we can do is we can kind of sort of contain the exception and wrap it into a safe API. So the way that would look like is we would encapsulate the side effect of throwing an exception And when there is an exception thrown, we can now distinguish it here using, again, a sum type. Also, I'm referring to the type that we defined above, because if we recall, the actual definition for some unknown reason returns any in TypeScript. Let's see some usage. So this is specific to TypeScript, but again, this also applies to JavaScript as well. Now that you call safe.json parse, first of all, there is no circumstance now in which this would throw. So that's a nice property of this function compared to the original one. And you can use your standard everyday logic that you would use before to do error handling if you wanted to. With TypeScript, there's this idea of narrowing. So TypeScript is smart enough to know that you've done a check here. And now that you've done a check, anywhere after the if, TypeScript will know that this variable result is of this JSON type. So something TypeScript specific for you to know. And then this is basically the same thing as before. So we do an addition to the return type of our function to distinguish between the different possibilities that could go wrong in our system. So some other observations. So something that I find like fascinating, I guess, really interesting, is that now you don't really need to read the documentation if you didn't want to, or I don't know, if there wasn't documentation. The code is more, the behavior is more accurate in the types than it was before. So before, you had to read the types, and you also had to read the, for example, Mozilla documentation. Oh, I'm losing my voice. Give me 1 second. Yeah, so whereas before you had to both read the types and also go to Mozilla's documents and see if that particular function threw, now you don't have to do that. It's all baked into your types. And also, because now these functions don't throw, you don't have necessarily runtime errors. The compiler can tell you, hey, you haven't checked whether this thing is successful or failed. So your compiler will even prevent you from shipping code to production that would have otherwise, thrown an exception, without this pattern. And then there's a pattern that we've been using. If you've noticed, it's simply, or the pattern is returns this or that. So how do we generalize that idea of, this function returns this on success and that on failure? Most of the time, you'll have a type that kind of looks like this. So now we're distinguishing between the result, the success case, and the error case. And in TypeScript, again, you can use this feature called narrowing, where once you check if a value is success, the compiler will know that there's a field called value of some type. Or if you check in an if statement that your result is an error, then it'll know that your value is a different type. So in practice, if we were to refactor our division function again, it would look a little bit different, and there would be a lot more boilerplate for sure. But conceptually, the idea is the same. However, I'm sure a lot of you are asking, what's the point of this, like, questionably unnecessary, object that you have to wrap things into, as opposed to what we did originally of having like this sum type? Yeah, and the answer is, like, right now there is no benefit, but in the real world, that's not how a result actually is implemented. And I actually don't know where we are for time, but that's kind of like where we can dive into next. This idea of like having this like package that you wrap your computations into provides you with a whole bunch of features, so to speak. And so actually, I wrote a package called Neverthrow, which does indeed implement an actual or a useful version of a result. So yeah, I'm going to leave it at that. There's a whole bunch of other stuff that we can talk about, but again, I don't know where we are for time. Or
You're totally fine on time. Take as much time as you want.
Cool. Okay, so yeah, I have this package called neverthrow, which basically extends on this idea of a result to help you distinguish between success and failure. And so let's look at some actual examples where, well, actually, before I scroll too much, let me first show you what the API looks like. There's this handy dandy package called neverthrow, and there's two functions, okay, and error, and then there's our type. The type behaves the same as it did before, except now it has a whole bunch of methods. So if I return an error variant like this, I have to call this function. And if I return, if I want to signal success, basically, I have to call this function, this OK function. And what that allows me to do once I have this type from neverthrow is you can have kind of this like idea. The way I think about it is kind of like having a computational context. So I have this like box that I can work with that allows me to do computations on code inside of a result. So when something succeeds, I want to map it into a string. And then maybe I want to do more division, but division itself, again, might fail. And then maybe I want to do something with the error. And then at the end, I want to unwrap it with a default value. So you can have these really long chains of computations. And if folks here are familiar with promises, it's kind of taking that idea of being able to chain computations inside of a box that may or may not fail. Or, for example, if you divide by 0 in this case, this actually won't get called. So it behaves pretty similarly to the then method inside of a promise. So yeah, another example would be, this is actually from our company's, so this is like, not IP necessarily. It's just code that I was able to grab without necessarily sharing company information. This is like real life production code that we use. We have an asynchronous version of the result that behaves exactly the same, except it allows us to basically await. So this is something we can await. And you can see here that we have a new result that I've developed or defined, I guess, that defines a computation that might succeed with some success value. And then we have a query error that is the sum of a whole bunch of different errors. And then in another file, the way that would look like is, this is another function from our code base. We're doing a query here. We have access control lists. We have some filters. And then here we return a result. And so that result that we have, if I could show you, which I cannot, you would see a lot of computations like this where we continue to work with the data inside of a sort of like safe context. I think, yeah, so there's some other stuff there, but it's kind of a little disorganized. So I'll leave it at that. And hopefully this was informative.
Cool, thanks. Nice talk. So now if people have questions, you can post them in the chat, and I will relay them to Gio. But in the meantime, I will ask you some of my questions.
Sure.
So, your talk assumed that you would be going to be using TypeScript for for all this code. And my question, as someone who hasn't jumped on that train yet, is assuming that I wasn't using TypeScript, wouldn't it seems to me like returning these these objects that are representing the result, but instead of throwing would make it harder for me to catch errors immediately. I think, unless I'm missing something. Like, there's no help from the compiler that's going to tell me that like I didn't check that it's instance of whatever error, or that if I'm using never throw your library, there's nothing checking that I'm going to check the type field. So I might just reach in and assume that I can get the value, the result out, and then it'll crash. Maybe down the line, maybe it will, maybe it'll give me undefined or something, and then it won't be caught for a while. So is TypeScript like integral part of this solution? Do you have to use it with never throw in order to get any benefit?
I personally, like I have jumped the TypeScript bandwagon a while ago, so I haven't really tried using never throw itself with with JavaScript. However, the npm package itself is just JavaScript with a type definition on top of it. So yeah, there is nothing preventing you from npm installing it and running it outside of TypeScript. And in fact, actually, like when I'm like prototyping ideas, I'll just pull up a REPL or something, and prototype ideas on my terminal without using types. But yeah, like if you don't have, for example, ESLint or JSDoc or something that's actually checking to see whether some variable is a particular, is it a result or is it just like a number? Mm-hmm. Then yeah, I think it will lead to a lot of headaches. And I think to a large extent, this idea is it kind of like runs counter to like this other philosophy of like throwing exceptions and then catching them early, or the sort of pattern, a more traditional pattern in JavaScript. It definitely runs counter to that. And actually, in my previous company, there was sort of like contention around that, where we had never throw in some parts of the code, but then in the same like file, potentially there would be a thrown exception. And so it's like, okay, well, how does that work? At Caribou, my current company, we've just collectively agreed that we don't, we're not going to throw exceptions unless there is like a circumstance where we want like our system to actually shut down, stop running, and let's like investigate what's happening. In those circumstances, in the other circumstances where, like, again, division by zero, as a developer, I should expect that sometimes I might divide by zero. And so like, it's my responsibility to handle it. I shouldn't necessarily throw an exception. And maybe, again, because we're using TypeScript, it just works a little bit better for us. I don't know if that answers your question, but.
I guess like a follow-up would be like, how would you summarize the benefit of never throwing and kind of forcing users to like check this return value instead? Like what is the, besides it sort of changing the shape of your code to a form that maybe you find more aesthetic, or I don't know, because I do think like try catch is a decent amount of boilerplate in terms of, like every time you want to do JSON parse, it's like a 5 or 6 line thing, because you have to put all this, this stuff like right around it. And then there's like the scoping issue with like, if you want to save the result in a variable, you have to declare the variable outside of the try. And it's a little bit inelegant in some ways, but yeah, like besides that, like, I don't know, like what are the sort of benefits that you see from changing to this model?
Well, so actually I can probably pull up this other slide. So one of the things I wanted to talk about was around try-catch semantics. Where is it? So yeah, I was going to go off on a whole rant about try-catch, and I think sometimes this is not necessarily like indicative of most situations, but these nested try-catch things are things that I have personally seen. They are real. They do happen. And so like, if we truly as developers did like really adhere to this, then we would have this much more often. But but the reality is we make subconscious risk assessments, and we say, well, when I call JSON parse, there's like a 99% chance, given my context, given my company, given what I'm doing, that this is just not going to throw, so I'm not even going to bother wrapping it in try catch, right? So there's like this like risk assessment we all make, and we look for simplicity and readability a lot of times in exchange for wrapping things in this try catch. The other thing too that you were touching upon, or I guess that you kind of reminded me about, is that the semantics of try catch are ambiguous by definition. So what does that mean? That means that, you know, even if you have a function that's guaranteed to only throw one exception, there is no way to prove that. There is no way to like actually know that like this e variable is indeed that thing that you as a human know, you know, is going to be that thing. And that's why in TypeScript, at least, the type is always any and unknown. And like if you try to explicitly annotate it to have a more specific type, you're going to get told like, no, like you can't guarantee that, you can't prove that. So where was I going with that? I'm not entirely sure, but I just wanted to share that. Yeah.
Makes sense. Yeah. So did you ever get a good answer to the question why some functions throw and some don't from the spec people?
No, yet to reach out to ECMAScript.
Mm-hmm.
Yeah. And I guess the other thing too is I think it's a matter of preference, kind of like what you were saying as well. Personally, I'm a huge fan of functional programming. I love declarative code where there's just these steps that just sort of say, this is what I want next, or this is what the state of the world is. And this pattern definitely lends itself to that. But, you know, other people have their preferences, and yeah, this is definitely not a silver bullet or anything. It's just I think, yeah, code style or an alternative for sure. Yeah.
Yeah, that's what it sounds like to me. It's sort of like almost like trying to bring paradigms that make sense in or like are better supported maybe in other languages and bring them to JavaScript. And you know, your allusion to the way that it kind of feels like a promise, but it's not. You know, it's not a promise. I guess the result type is a promise, you said, but or it has the same methods that a promise would have. Is that right? Oh, it doesn't. Oh, okay.
Okay, so yeah, a result. There's two. So can I share my screen again?
Yeah, sure.
So there's the two examples I had. So this is, yeah, so the never throw package exposes two different results. This one is synchronous. So think of it as like any other data structure that you might use on your day-to-day basis, such as like a map or an array or an object. And it has a whole bunch of methods that allow you to operate on the contents of that result. So for example, a map method allows you to operate on the success value of the result. So in this particular case, the type of the type of this argument would be number. And then map error, in this particular case, error message would be this string literal. However, neverthrow also exposes an asynchronous API, which basically is a replacement to promises. So yeah, this can be a drop-in replacement to promises. And the reason you'd want to do that is because not only do you have .then, .catch, .finally, but you have all of these other methods on top of the promise that allow you to do declarative programming. So it kind of goes back again to the style of programming, where rather than throwing exceptions, you maybe have like a declarative style of writing code that lends and this lends itself to that, basically.
Right, that makes sense. Let's take a question from the audience now, I think. So there's a question here about, and actually this is something I was wondering about too, is, you know, kind of what you're showing reminded me a little bit of the way that Node.js handles its errors. Well, in the callback style, where you're, I mean, you don't have help from the type system that's going to actually check that you are handling the error, but it's returned to you, and it's, you know, it's kind of a part of the contract that functions that take callbacks won't throw. Although that's not entirely true. They throw in the case where you like give it a completely bad argument, then they'll throw to kind of alert you right away that like, they want your program to crash because you okay, I'm going off on tangent, but yeah, basically in Node, things throw when like, the parameters are could never work. There's no way, like it's almost like you want it to be an error that surfaces to the programmer immediately rather than something that you catch at runtime. Yeah, but ignoring that case for a second, basically, yeah, you get this like error and then you get this result value and then you just are supposed to remember to handle the error. And I guess that's similar to, according to this questioner, I haven't written Go, but it's apparently similar to how Go approaches errors, where you get the error first and then you get the value. And this person's just wondering like what your thoughts are on that style and how, I guess, maybe how it compares to never throw.
Yeah, so Go's approach is similar to the error first callbacks in Node, where you have to rely on developers' discipline and potentially code review or a manual process to ensure that someone literally wrote code to ensure that that error value wasn't ignored. Whereas with this algebraic data type approach, you kind of have like a almost like a Schrodinger's box, so to speak, where like you're not going to get both a success and a failure value in a variable. It's either or. So it's similar, although I think a little bit potentially more unintuitive.
Right. Yeah, I've always wondered in the case where you return an error. I usually return null or something for the value, but there's no guarantee that you do that in Node. So I see when you make it a type, it's like you're forced to make it either or, and you get some consistency similar to how like promises make promises improve upon the callback pattern by giving you a guaranteed either or, and forcing you to address the fact. I guess. Kind of forcing you to address the fact that it could be an error explicitly by like awaiting it or calling then on it.
Yeah, I guess like to circle back is like a lot of the times potentially because of bad habits or for whatever reason, in the case of say Node with error first callbacks, people will not have the if statement and they'll always assume that that function succeeds. Or in the case of Go, they'll ignore that error value and things will just proceed. And with never throw or this any algebraic data type, you can't do that. You can't assume. So that's one of the nice properties with this other style of programming.
Mm-hmm. Yeah. Another question is this is a good one. So one cool thing about throw is that it can be handled anywhere up the stack instead of only locally, if that's what you want to do. And so, one like, use case for that is like, the JSON parse example you used, if you want, you can have like a try catch at the top of your program that just, gracefully handles the error without crashing the process, and just tells the user, something went wrong. I have no idea why, because I'm catching it at the top level. But you can, and then in a sense, you can like freely code without worrying about try catch if you're being lazy, or if you forget it in one place. There's like at least sort of a path to like how it's kind of handled relatively elegantly, even though like in theory you could have handled it better, more like closer to the source of the site of the error. So yeah, this question is really good. I'm really curious, like if there's a way to kind of propagate an error result in this model up to the top. Is there some way to like hack it with throw, or how? Like, because I don't think the language is going to support you here.
Yeah. So I mean, as much of a almost like, yeah, like I'm not a Puritan, like I also throw exceptions, but it's really nice because ultimately inside. So if we go back to my code examples. In any of these callback functions, like this is just JavaScript, right? So inside of any of these things, you're free to throw an exception, right? So there's nothing that's going to stop you from, or there's nothing that never throw will do to prevent you from throwing exceptions. And so you can totally do that if you want to. And the only thing with Neverthrow or these other packages is that they're simply like just trying to promote discipline. It's like they're kind of like making it hard for you to be lazy. And so yeah, you're being faced with the decision of having to deal with an error right away. But yeah, you can totally throw exceptions anywhere and have like a global catch handler. And personally, our team doesn't have that, but we do have different situations where we throw exceptions. So one example is when our server initializes, we do a bunch of checks on our environment variables. And if something's wrong with our environment variables, we immediately shut down. And the way we shut down is through throwing an exception. So yeah, like I think any team will have a healthy mix of these different things. But I guess kind of like the point that I'm trying to drive home as well is that I think we all as developers can probably throw less exceptions, at least with TypeScript. I don't know. Yeah, again, I don't know how ergonomic that would be with JavaScript.
Right. Well, there's a few other good questions in the chat that I passed over, so apologies if I skipped your question, but that's all the questions we have time for right now. So thanks so much for joining. Gio, I appreciate you sharing your talk with us.
Thanks so much, Ross.